We're doing non-parametric tests. I think we have defined what is parameter. Parametric test we have defined in previous class and previous week. We have given all the most of the parametric tests mostly with mean, population mean and population proportion, and then comparison of mean. So non-parametric tests where I think I have said that previously, that where no specific value of the parameter will be given or will be tested, and and instead of that, certain criteria, certain different type of criteria will be tested with respect to uh, population, but obviously it is related to the population. And there's a non-parametric test is also very much important in case of for the students of marketing, because marketing specialization, the all the decision making process are being done with the help of the parametric test as well as the non-parametric test. Before going to the non-parametric test, let's define one more probability distribution, continuous probability distribution, and how the it looks like. In fact, the distribution that I'm talking about called chi-square distribution. This is written as CHISQUARE, chi-square distribution. The distribution, the probability density function is not distribution. Probability density function is not important, but the property of the how the graph looks like, it is important. So let's draw the graph of chi-square. Chi-square looks like this type. Chi-square is a variable which is from 0 to infinity. So the graph starts from 0, and initially it is steep and then it flattens. It's flatter. It's not symmetric. It is not a symmetric graph, and obviously area under the curve similar to that of the whole is the total probability. And what is this value? Who can tell me what is the value? What is the area under the curve? This is y equals to chi-square is the graph, and the area under the curve will be equals to,
Sir, 1.
yes, is the sum of the probabilities, and that is equals to 1. Yes. So as same as that of the all other curves we have talked about. So chi-square is a variable, is a continuous variable. So the distribution is a continuous probability distribution. So this is the curve y equals to chi-square. The name is chi-square, and it is not symmetric. So this is a distribution which is not symmetric. So for a point alpha, if it is a two-tailed test, the value of chi-square alpha by 2 and chi-square alpha by 2, both of them has to be provided. Otherwise, so that will mean this area is alpha by 2 and this area is alpha by 2 for a test where level of significance is alpha. But this is not symmetric, both the values has to be provided. But we will discuss this later. Initially, we will start with the chi-square. The chi-square is generally for non-parametric test. Chi-square is a very important kind of distribution. Chi-square distribution is used for two types of non-parametric test. One is called chi-square as goodness of fit, and number two is chi-square as the test of independence, as test of independence. So we will discuss both. We will discuss both. We'll start with chi-square as goodness of fit. So we'll discuss chi-square as goodness of fit first. Now what does it mean that chi-square as a goodness of fit? Let's give an example how chi-square can be treated as a goodness of fit. Let's please write a problem like I'm giving. Then I'll explain what is the chi-square as a goodness of fit problem, and then we can go into solving some other problems. So let's discuss that. Uh, Please write. Uh,
Yes,
let's
sir.
write question. A dice is thrown 120 times. A dice is thrown 120 times, and the six faces 1, 2, 3, 4, 5, and 6 came up 20, 25, 18, 16, 30, কত রইল? So 20 plus 30 is 50, 50 plus 25 is uh, 50 plus 25 is 75, plus 18 plus 16 equals to 109. So 120, that means it will be 19. So the six phases, phase 1 came up 20 times, phase 2 came up 25 times, phase 3 came up 18 times, phase 4 came up 16 times, phase 3, sorry, this is phase 5 came up 30 times, phase 6 came up 19 times. Can we say that Can we say that the dice is unbiased? Can we say that the dice is unbiased? Test at 5% level of significance. Can we say that the dice is unbiased? Test at 5% level of significance. Okay? So this is the question. So what is happening here? Here we are trying to fit a
So
probability
test
distribution.
that.
Test at 5% level of significance. 5% level of significance, whether the dice is unbiased
Yes, sir.
unbiased or not. Okay, so please write the data. I don't have the data, so please write the data and we will explain the problem. Okay, so here we are not testing. Why this is called a non-parametric test? Here we are not testing some value of mean or median or more mean or say or standard deviation or population proportion. We are not trying to test. Here we are trying to test whether the distribution, means what actually happens if you are tossing a dice 120 times, and you know each face probability, what is the probability of each face coming up is 1 by 6, isn't it? If you are throwing a die,
Yes, sir.
so each face probability of coming up of each face is 1 by 6. So that means out of 120 times, everyone will be coming as 20 times. Taito? Phase 1 will come up, supposed to. It's not necessarily true, but in real life that may not happen. In real life that may not happen. So in real life this is what happened. So with that result, can we check, can we test whether this is an unbiased die? যদি একটা পার্টিকুলার, আমরা যখন ছোটবেলায় লুডো খেলতাম, যে ছয় পড়বার জন্য ট্রাই টু মেক হাউ ইট ইজ whether the six comes up or not frequently. So we try to do that. But if it's an unbiased die, then it is supposed to be near about 20, all of them. But if this is the kind of result that we are getting, whether we can tell the dice is biased or unbiased. Unbiased means here we are trying to find out whether the dice is unbiased, means whether all the faces has equal probability to come up, whether all the faces are equal probability to come up. So that is how we are going to test, and how good the fit is. That means this data that we have already obtained, how it is realistically probable to fit with the real life actual data, or sorry, how the real life data is related to uh, fit with the standard problem. So that is what our discussion is. Our objective is to find out how good the fit is. Fit here, fit means we are trying to fit a distribution. We are trying to fit a probability distribution with respect to the population, and how this sample data or obtained data or observed data, how that helps to fit whether that observed data is similar to that of the population characteristics or not. That is what we are trying to find out, and that is why it is called as chi-square as goodness of fit. So for that, what we do before going into the details, we'll just explain a little bit more, then we'll do this problem. So I'm rubbing this off. Now chi-square, please write chi-square as goodness of fit is a, it is always a right tail test where the level of significance or critical region always lies at the where the level of significance or the critical region, this is the critical region corresponding to the level of significance. So critical region lies to the right of the acceptance region. So this is the CR bar acceptance region, and this is the critical region, and this particular point is a chi-square value with n minus 1, sorry, k minus 1 degrees of freedom. K minus 1 degrees of freedom. Now chi-square distribution, I have missed it. Chi-square in this case, chi-square has always has a degrees of freedom, and here it is k minus 1 degrees of freedom, and where k is the number of groups, where k is the number of groups, and this is a chi-square k minus 1, chi-square with k minus 1 degrees of freedom, and k, where k is the number of groups. Mind that in this case the null hypothesis and alternate hypothesis will be writing that alternate hypothesis is always not equals to, but it is not a two-tailed test. It is always a right-tailed test, and chi-square as a goodness of fit is always a right-tailed test, and we define chi-square is this way, is equals to the test statistic chi-square is defined as summation of FO minus FE whole square by FE, where FO is the observed frequency, FO is observed frequency, FE is the expected frequency, FE is the expected frequency, and our job is to find out the FE. FO is already given, observed frequency that I have already given. So FO is already given. FE we have to calculate from the probability distribution, that is what we are going to test, and then we will find out this chi-square value, and according to the table of the chi-square we will find out where the value falls. If the value, if chi-square calculated is greater than chi-square tabulated, I have already provided you the table, so I will check that. I-square chi-square calculated is greater than chi-square tabulated, then null hypothesis is কি হবে? Hypothesis is rejected. Null hypothesis is rejected because chi-square calculated is greater than chi-square tabulated, means it will fall in the critical region, and thus null hypothesis will be rejected and alternate hypothesis will be accepted, and alternate hypothesis accepted. Okay, so that is the process of using chi-square distribution as a goodness of fit, So let's solve this problem, the problem that I have already given. So let's solve. Let's write down the null hypothesis and alternate hypothesis from the beginning for the problem that I have given. So please write null hypothesis H naught. H naught is the die is the dice is unbiased. That implies the faces 1 is to 2 is to 3 is to 4 is to 5 is to 6, because a die has 6 faces. So face 1, face 2, face 3, face 4, face 5 and 6, all of them are equally likely. Their ratio will be কি হবে 1 is to 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 1. So all of them are equally. তাহলে তো হবে probability 1 by 6. Or you can write the other way around. The die is unbiased means each face will be having probability 1 by 6. You can write that also. If that is the case, then the die is unbiased. And the alternate hypothesis is the dice is biased. That means implies they are not equals to 1 is to 1 is to 1. ঠিক আছে 1 is to 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 1 2 3 4 5 6 1. So that is the null hypothesis. Always for a test of significance, always write the null hypothesis and alternate hypothesis. Okay, fine. Is it okay?
Yes, sir.
Okay.
Yes, sir.
Then we will do the table. Then we will make a chi-square calculation table. So let's write the chi-square calculation table. So we'll be using this. Let's write the chi-square calculation table. So we'll write this way. First column is groups or then FO, then FE, then FO minus FE দরকার নেই. If you want to write, you can write, but our important is FO. In fact, FO minus FE whole square একবারে করে দাও. FO minus এটা FO minus FE whole square, FO minus FE square by FE. আমার FO minus FE square by FE. Last column টা হবে I'm not, so please write on the top FO minus FE উপরেরটা স্কয়ার নিচেরটা স্কয়ার নয় কিন্তু by FE. Okay, so in this case how many groups we have? We have 6 groups. Phase 1, phase 2, 3, 4, 5 and 6. These are the 6 phases. So 6 groups. So what is FO? FO is the observed frequency. So observed frequency কত দিয়েছি? What are the values? কি কি দিয়েছি বলো? 20
5
তারপরটা
18
20 পর 18,
হ্যাঁ 18 স্যার
then
16 30 19
কোথায় হলো 20?
Sir, 22, 25,
না স্যার
তারপরে 18, তারপরে 16.
আস্তে আস্তে একে একে 20 এর পরে ফেজ 2 এর জন্য কি দিয়েছি?
25,
25,
25
18,
yes sir
16,
তারপর 18
30,
16
19. তাই তো? So this is observed frequency. This is observed frequency FO. And FE will be calculated by the null hypothesis value. Expected frequency will be calculated by the null hypothesis. So here total is 120. তাই তো? Total is 120, isn't it? So total is 120. So FE
Yes,
is
sir.
120 into 1 by 6. So FE is, কারণ রেশিও হচ্ছে 1 by 6, তো 1 is to 1 is to 1 is to 1 is to 1 মানে all of this, there are 6 cases, so probability is 1 by 6. Either you write probability or you write, so it is 20.
So 128 total.
কি করে 128 হয়? যোগ করো তো, যোগ করো 20 plus 25 plus 18 plus 16 plus
হ্যাঁ স্যার 128
plus 19 128 হয়ে গেছে।
Yes, sir.
তাহলে তো ভুলভাল করে দিয়েছি, একটা ডেটা চেঞ্জ করে দাও 19টাকে।
স্যার 19টাকে 11 করে দিন তাহলেই হয়ে যাবে।
হ্যাঁ 19টাকে 11 করে দাও, 19টাকে 11 করে দাও, 19টাকে 11 করে দাও। ও আমি ভুল করে ওই লাস্টে সাম করতে গন্ডগোল করেছিলাম। ইয়েস 19টাকে 11 করে দাও, জাস্ট ফর দ্য সেক অফ দ্য ডিসকাশন। 19 হলে হতো খুব একটা খারাপ, ক্যালকুলেশনটা বাজে হয়ে যেত, দ্য ক্যালকুলেশন উড হ্যাভ বিন ভেরি ব্যাড। ইনস্টেড অফ 20 এখানে 20 পয়েন্ট সামথিং চলে আসতো। সো আমি ক্যালকুলেশনটা সিম্পল করার জন্য উই আর জাস্ট ডুইং দ্যাট। ওকে, সো expected frequency is 120 by 6, so all of them are 120 into 1 by 6. so প্রত্যেকটাই তো যদি আনবায়াসড কয়েন হয় তো অনবায়াসড ডাই হয় তাহলে প্রত্যেকটাই 20 বার করে পড়ার কথা ছিল, বিকজ দ্য টোটাল ইজ 120 and there are 6 faces. so each of them will be 20. Got it? Now you calculate these parts.
Yes, sir.
So now you calculate these parts and tell me what are the values. Calculate these parts and then we'll write down the value. So please, this is 0, this is 5 square, this is 2 square, this is 4 square, this is 10 square, and this is 11 square. And this will be each of them will be divided by 20, isn't it? Because each of the cases মুখে মুখে কোনো ক্যালকুলেটর লাগে না, তাই না? 20 minus 20 is 0, so 0 square. 25 minus 20 is 5, so 5 square. 18 minus 20 is 2 square করলে minus or plus will not make any difference.
স্যার লাস্টে তো 9 স্কয়ার হবে।
11 9 square হবে, ঠিক 9 square হবে। হ্যাঁ, I want to make mistake so that you can correct me. That's right. Yes, 20 minus 11 is 9 square. Fine. So please, and finally, so FE, FO minus FE, so each of them will be divided by 20. And finally, so I have written chi square is equals to summation of FO minus FE square by FE. So that means this is equals to 0 plus 5 square by 20, তারপর একটা 2 square by 20 নাকি, তারপর একটা কত ছিল, তারপর একটা 4 square by 20,
লাস্টেরটা তো?
হ্যাঁ
হ্যাঁ স্যার।
10 square by
20 plus
9 square by
by
20
20, তাহলে কত হয়? How much is this? Calculate. So 25 plus 4 এ 29, so that is 25 plus 4 plus 16 plus 100 plus 81, 226 by 20, so 11.3. তাই হচ্ছে value of chi square is 11.3. Are you getting it? Students,
Yes, sir.
reply. Just calculate.
Yes, sir.
Because chi square is sum of all those values. And now we have to check the table. See, I have already sent you the table of chi square. So this is the calculated value of the chi square. And so we have to check the tabulated value. Now for 5% level of significance, we have to check chi square. How many degrees of freedom? There are 6 groups. So k minus 1, that means chi square with 5 degrees of freedom. K is 6, so k minus 1 is 5. At 5% level of significance, look at the table that I have already provided. Chi square is the first table. So chi square at 5, it's 11.1, isn't it? At 5% level of significance, chi square at 5% level of significance and 5 degrees of freedom, the value is 11 point. We write this way: chi square
স্যার 11.3 বেরিয়েছিল তো।
5 না না, আরে বাবা এটা ট্যাবুলেটেড ভ্যালু, টেবিল থেকে we are looking at
ওকে
the
স্যার।
table. I have already 11 chi-square and at 5% level so this is the degrees of freedom, mind that it's k minus 1 and this is the level of significance. This is how it is, right? This is equals to 11.1, the tabulated value. This is the tabulated value and the calculated value we have got is how much? Is 11.3.
3.
So we'll write this way: chi-square calculated, that is 11.3, is greater than chi-square tabulated, that is কত 11.1
1.
at 5% level of significance with 5 degrees of freedom. Hence the null hypothesis is rejected. So we can say that the die is, what will be the decision? The
স্যার
die is
biased.
Biased. Biased.
die is biased. Null hypothesis is rejected. Alternate hypothesis is accepted. So in the alternate hypothesis we have written the die is biased. So that means the decision is the die is biased. Okay? So that completes the problem.
Results of 500 students was made.
So
It was found.
total number of students is 500.
Yes, sir.
Students. Okay. So 500 students. Yes, it was found.
It was found that 220 students has failed.
So failed 220.
Yes, sir.
220. Once one বড়
170 had secured a third class.
third class 170. Okay.
170. Yes, sir. And 90 were placed in second class.
90 in second class. 90.
Yes. And 20 got a first class.
20 got a first class. First class 20.
Yes, sir. Are these figures comments?
Commensurate.
Sir, কি লেখা আছে?
Commensurate with
Commensurate with the general examination result,
which is in the ratio.
which is in the ratio of 4:3:2:1 for the various categories respectively.
So what will be the null hypothesis? What will be the null hypothesis? What will be the null hypothesis? বলো। The null hypothesis is the result is commensurate with the general examination result. That is, please write, the result is commensurate with the general examination result. That is, fail H2 third class, H2 second class, H2 first class is 4:2.
500.
No, H2 4 ratio to. We are writing the ratio
Oh,
4:3,
okay, sir.
2:1. So this is how we should write. This is how we should write. Null hypothesis, we should write this. The ratio of fail H2 third class, H2 second class, H2 first class is 4:2, 3:2, 2:1. An alternate hypothesis is the ratio is not commensurate with. So the ratio is not commensurate with this particular. So not equals to, ratio not equals to this 4:2, 3:2, 2:1. So this is how we write. Then we do the simply calculate the table. So calculate the table for calculating the chi-square. So groups fail third class, second class and first class, FO Fe, FO minus Fe square, and FO minus Fe whole square by Fe. So what is FO? বলো কি কি দেওয়া আছে? FO is 220,
220. Third class is 170.
then 90
Second class is 90.
and 20. Total is
Yes, sir.
500.
500.
So Fe is 500 into 4 by 10, তাই তো? Total ratio কি?
Yes, sir.
4.
500 into 4 by 10.
That means এটা 200 হবে, তাই তো?
200. Yes, sir.
So 200, then 150, তাই তো?
Yes, sir.
Then 100
100.
and 50.
Then 50.
ঠিক করেছি?
Yes, sir.
And then calculate. So this is 20 square, this is also 20 square, this is 10 square, and this is 30 square. So chi square, here see Fe values are different. So this will be, first one is 20 square by, first one is, bolo, 20 square by 200. Second one is 20 square by 150. Third one is 10 square by 100 হবে না? 10 square by 100, and fourth one is 30 square by 50. And after you get these values, just add this column, last column. That will give you the value of the chi square. So what is the value of the chi square? The value of the chi square is 20 square by 200 plus 20 square by 150 plus 10 square by 100 plus 30 square by 50. So how much is the value? What did you get? See, please students, please tell me what is the value that you have got. এতক্ষণ লাগে কি করে? আমি তো ক্যালকুলেটর ছাড়াই করছি। How much is the value?
It's a 9.266.
No, it is 23.7.
23.66.
23.67.
Yes, sir. 23.667.
Yes, chi square is 23.667. হ্যাঁ, কি করে 9 পয়েন্ট পেলে? কে কি করে পেয়েছো? শোনো, এই ভ্যালু ক্যালকুলেশন যদি ভুল করো তাহলে আমার আর কিছু করার নেই। It is simple, everything is specified, only you have to put the values. There is no difficulty at all. So this is the calculated chi square value, chi square calculated value. And what will be the chi square tabulated value at 5% level of significance? How many degrees of freedom in this case? How many degrees of freedom? So chi square 3.05. Because there are 4 groups, so k minus 1 is 3. So 3 degrees of freedom, value is 7.81.
81. Yes, sir.
7.81 from the table you can check. So chi square calculated is greater than chi square tabulated, তাই তো?
Yes, sir.
So that means null hypothesis is rejected. So and alternate hypothesis is accepted. So we cannot say that the result is commensurate with the ratio 4:3:2:1. So that is the answer. So after we have discussed chi square as goodness of fit, now we'll discuss chi square as degree of association. Or degree of independence. একই মানে। Say how we can explain the chi square as degree of association or chi square as degree of independence. So here also let's take an example and explain with the help of the example, and then we will calculate this chi-square and use how chi-square can be. See, try to understand the difference between the problems. The calculation part is really very easy, but understanding the problem is important. How it is different from chi-square as a goodness of fit and chi-square as a degree of association and degree of independence. So let's discuss an example. So let's take an example with what is that's the current situation. So current situation. So what is happening with the let's just an example like so we know that nowadays there is a for COVID there is vaccination is taking place, and there is a vaccine Covishield. So we want to test the effectiveness, how this effectiveness of Covishield is being tested. See, for this you can use this degree of association. Ki kore? Let's try to write an example. Say, think about, please listen carefully. Say, people, there are, there are two types of, say we have chosen, say 500 people. 500 people are chosen, out of them vaccinated and not vaccinated, okay? So out of 500 people, 300 people are vaccinated and 200 people are not vaccinated. Okay, out of 500 people, 200 people are not vaccinated, given the vaccine, and 300 people has been vaccinated. And out of those 300 people, the table will be a little different. Out of this 300 people, let's write this way: vaccinated, yes, no, are contracted, yes, no. So that means total So here yes means the people who are vaccinated but still contracted the COVID. তাদের কোভিড হয়েছে, সে এরকম আছে, সে ধরো 50 জন, আর ভ্যাকসিনেটেড and not contracted হতো ধরো 250 জন. So I said total vaccinated is 300 and total not vaccinated is 200. So out of 200, 100 is not vaccinated, not contracted, and 100 not contracted. So do you get my point? কি বলতে চাইছি? 500 people are chosen. 500 people are chosen. Out of them, 300 people were vaccinated. Yes. So this is vaccinated part. Yes. So that means 300 people are vaccinated and 200 people are not vaccinated. Okay. So those who are vaccinated, out of these 300 people, 50 people got COVID. Although they are vaccinated, they are still had COVID, and 250 people did not contracted COVID. They didn't have COVID. And out of 200 people who are not vaccinated, 100 of them had COVID and 100 of them did not have COVID. Now the question is, so that means how many total? Yes, this is 150 and this is 350. This is root. So can we say that? Can it be tested that the COVID vaccination, the vaccine is effective to the people, effective? Can we say that the vaccine is effective on the people? So this can be tested by that degree of association or degree of independence of chi-square test. This is a question where we can use chi-square as degree of association. So how to do it? Please write down the null hypothesis and write down the alternate hypothesis. Now every time you write down the null hypothesis in case of degree of association, so here the null hypothesis is always that the vaccine is independent of vaccination is independent in this case, or you can say vaccination is not uh, no dependency. When I the what was the question? I can't remember what we have said initially. Whether the vaccination is effective and whether the vaccination is not effective. So null hypothesis vaccination is not effective. Vaccination is not effective. And alternate hypothesis is vaccination is effective. In mathematical term, you can say the result is independent of the COVID. The experiment result is independent of vaccination. Null hypothesis can be written as means, or you can write that as vaccination এর সঙ্গে contract কি বলে effective means with respect to the vaccination there is no relation of getting cured. We can write the table in a different manner also. So cured, not cured, vaccinated, not vaccinated. So like that. So vaccinated, cured, how many chilo? I think I have written 250 na. Vaccinated, not cured was 50, তাই তো? Vaccinated, not cured was 50.
Yes.
And
Yes, sir.
not vaccinated, cured was 100, and not vaccinated, not cured was also 100. So
Yes, sir.
that was the table. So I can write vaccination, vaccinated, not vaccinated, cured, not cured. এরকম ভাবে ওই টেবিলটাকে লেখা যায়. So how the table is given accordingly you can write. So vaccination is effective and vaccination is not effective. Mind that the null hypothesis is vaccination is not effective. The alternate hypothesis is vaccination is effective. So vaccination is not effective means the cure is independent of vaccination. So you can write the null hypothesis as cure is, so H naught you can write cure is independent of vaccination. Okay, and alternate hypothesis is cure is dependent on vaccination. ঠিক আছে? So this is how we will write down the null hypothesis and alternate hypothesis. Now again because it's a chi-square, so we will be using the same formula for calculating chi-square. So how we will calculate chi-square as it is a summation of FO minus FE whole square by FE. FO is the observed frequency, FE is the expected frequency. Now here how FE will be calculated? It's pretty simple. Here FE will be calculated in a different manner. Here FE will be calculated by the formula. Here FE will be calculated by the formula row total into column total by the sum total. So row total into column total by sum total. That is how FE will be calculated, and then all other values will be calculated. And in this case, for degree of association or degree of independence, the chi-square as a goodness of fit is a chi-square distribution with r minus 1 into c minus 1 degrees of freedom. With r minus 1 into c minus 1 degrees of freedom, where r is the number of row, c is the number of column. So r minus 1 into c minus 1 degrees of freedom. So let's calculate for this particular problem. Let's calculate how to go about this. Oh, we have got the data. So B means vaccinated, NB means not vaccinated, C is cured, and NC is not cured. So we have the observed data as observed value as vaccinated cured as 250 and vaccinated not cured as 50. Uh, Not vaccinated cured is 100 and not vaccinated not cured is also 100. So that's what I have said. So here the row total it is 350 and here it is 150 and the column total it is 300 and it is 200. So FE, in this case FE will be, for this is row total is 350 and column total is 300. So, and the total is, sum total is 500. Sum total is 500. So this, in this case FE will be 350 into 300 by 500. So how much is that? 350 into 300
210.
divided by 500.
210.
210. So this is equals to 210. So obviously if it's 210, this will be 90. You can use the formula also. See, if you get one value, you can get the other values because it's the 2 cross 2. This is called a 2 cross 2 contingency table because all other values are given. So if this is 210, this will be 140. Has to be. You can check. You can check using the formula. This is 100 into, this will be 100 into 350 by 200. Sorry. This will be 350 into 200 by 500. This will be. Row total is 300, column total is 200, sum total is 500. So accordingly, this will be, AP will be 140, this is 90, and this will be 60. This will be 60. Please check. Use the formula. I have already given the formula. FE is equals to row total into column total divided by sum total. So in this case, this is 350 into 300 by 500. In this case, কি হবে কে বলবে বলো? This will be 300 into 150 by 500. In this case, row total is 150, column total is 300. So 300 into 150 by 500 gives you 90, and this way all the values can be calculated. So chi-square values, তাহলে chi-square values কি হবে বলো? So chi-square equals to, তাহলে chi-square will be equals to 40 square by 210, তাই তো? Observed frequency কত ছিল? Please, I have rubbed the table. Please somebody say. Observed frequency is 250. Hello? Student, please reply something.
Yes, sir.
বলো। Plus, আরে বলো মুখে। So what is the formula I have written? I have written the formula for chi-square as summation of FO minus FE, summation of কি formula কি FO
ও আচ্ছা হ্যাঁ স্যার
AP whole square by AP. So 250 minus 210 is 40. So 40 square by AP is 210. So that is one value. Then this is also সবকটাই 40 হচ্ছে, প্রত্যেকটাই 40 স্কয়ার, উপরেরটা সবকটাই 40, একটা হচ্ছে this is by 90 plus 40 square by 140 plus 40 square by 60. Isn't it? এখান থেকে এটা বিয়োগ করলেও 40 হয়, এটা বিয়োগ করলেও 40 হয়, এটা বিয়োগ করলেও 40, all of them are 40. So 40 square by 210 plus 40 square by, so 40 square by 210 plus 40 square
by 90
by 90
or 40
plus
square by
40
140
by 140 plus
40 square by 60
by 60 equals to 63.49. কত বেরিয়েছে করো?
স্যার 63.5 বেরিয়েছে।
হ্যাঁ 63.4,
এরকম।
so equals to 63.49. তুমি বেশি না, কত ঠিক আছে 49 আর 5 is, so that is the calculated value of the chi-square. And what is the tabulated value? Chi-square r minus 1 হচ্ছে 2 minus 1, তাই তো? There are two rows, so 2 minus 1 into 2 minus 1, there are two columns, so that means chi-square at 1 degrees of freedom with 5% level of significance. What is the value? Check the table I have provided. So check the table I have provided. What is the value? Chi-square at 1 degrees of freedom is 3.84.
3.84.
3.84. So this is the calculated value. This is the calculated value. Obviously, calculated value is greater than the tabulated value. So null hypothesis is rejected and alternate hypothesis is accepted, which means what is the decision? Final decision is the cure. Answer key. The cure depends upon vaccination, isn't it? The cure depends upon vaccination. So that is the decision that we get. Alternate hypothesis is the cure depends upon the vaccination. So please, so please take the vaccine whenever the vaccine comes to your. So please take the vaccination. Okay. So 11.5 it says 1,000 students at college level are graded according to their IQ level and their economic condition. Use chi-square test to find out whether there is any association between economic condition and IQ level. See the data, economic condition and IQ level. So economic condition, what are the two economic conditions? Rich and poor. So these are the two rich economic conditions. And IQ level, there are three different IQ levels: high, moderate and low. So high is 160, 140, moderate, medium is 300, 100, low 140, 160, and 600 total. So 600 rich স্টুডেন্টের সঙ্গে কথা হয়েছে আর 400 poor people ke, poor স্টুডেন্টের সঙ্গে. So the data is like that. There are three levels of IQ levels. High, so 160 students, rich student has high IQ level, and 140 has low IQ level. Similarly, 140 poor student has high IQ level and 100 poor student has this level. So can it be said that the find any association between economic condition and level of IQ? So what should be the null hypothesis? Pranto bolo to, what should be the null hypothesis? Pranto?
Yes, sir.
So what will be the null hypothesis? The null hypothesis will be,
This is
bolo, IQ is independent of economic condition. So H naught IQ level is independent of economic condition. That is null hypothesis. Independent. Mind that the null hypothesis will be independent. The alternate hypothesis will be dependent. So alternate hypothesis will be IQ is dependent on economic condition. ঠিক আছে? So null hypothesis is independent, IQ is independent of economic condition. Alternate hypothesis is IQ is dependent on. See, this is why it is called a parametric test, because here we are not testing in the value of any parameter. We are trying to discuss certain criteria about the population characteristics. Okay, so these are the F are given. So calculate FE, calculate FE. So calculate FE. So row total I have written, sorry, a column total. So this is 300, this is 400, and this is 300. So the first one, calculate kocho. The first one will be 600 into 300 divided by 1000. That is 180. So if it is 180, it must be 120 because total is 300, has to be. পরেরটা হচ্ছে next one is 600 into 400 divided by 1000, that is 240 নাকি? So this is 240, it must be 160. So 240 plus 180 become 8 12 420. So this must be 180. This is 180 and this is 120. This is 120. Okay, so please follow the formula. We have already written. So follow the formula. You can find out the values. These are FE. So we have found out FE. Now calculate the value of chi-square. So chi-square, first one, chi-square will be key. প্রথমটা কি? So 160 minus 180, that is 20 square by 180. So 20 square by 180 plus পরেরটাও তাই 20 square by 120 plus তারপরেরটা 60 square by 240, 60 square by 240 plus 60 square by 100, 60 square by 160, sorry, 60 square by
160
60 square by 160. তারপরেরটা হচ্ছে 20 square
40 square
by 180.
so 40
Sorry, 40 square by 180 plus 40 square by 120.
120
Square by 120. So please আমাকে আরেকবার বলো, I am writing. So chi square will be
20 square by 180
plus 20 square by 120.
120
তারপরটা হচ্ছে
60 square by 240
হ্যাঁ 240
60 square by 240 60 square by 160
160. And last one is 20 square na?
40 square
Oh, 40 square. 40 square by 180 plus 40
or
square
40 square 120.
So calculate the value of chi square. How much is this? So what we get is 20 square by 180 plus 20 square by 120. এর সবকটা ভ্যালু ডিফারেন্ট আছে। You have to
65.77 sir.
let's check. Plus 60 square by 240 plus 60 square by 160 plus 40 square by 180 plus 40 square by 120 gives you 65.27.
65.77 sir.
না 65.27 টাইপিং মিস্টেক। আর কেউ? আমি ভুল করলাম?
Yes, sir. 65.27.
777. So it's 65.28. It is 65.277 আছে, so 28. And this is the calculated value. And what will be the tabulated value? Degrees of freedom. What will be the degrees of freedom in this case? So chi square.
Sir, 2.
হ্যাঁ r মাইনাস ওয়ান হচ্ছে ইন্টু সি মাইনাস ওয়ান, সো r মাইনাস ওয়ান হচ্ছে 2 মাইনাস ওয়ান, c মাইনাস ওয়ান হচ্ছে 3 মাইনাস ওয়ান, তাই তো?
3 minus
There are
1.
three
Yes, sir.
columns, so 1 into 3, that means chi
Yes,
square
sir.
with
Yes, sir.
2 degrees of freedom. Chi square, so chi square is 2 degrees of freedom, and chi square 2 comma 0.05. This is how it is written. So what is the value বলো তো? So what is the value? Chi square দিয়েছি, what is the value? 2 degrees of freedom at 5% level is 5.99,
0.99.
0.99.
5.99, তাই তো?
Yes, sir.
5.99 is the, so calculated value is greater than the tabulated value, hence the null hypothesis is rejected. So we cannot say that the IQ level is independent of economic condition, তাই তো? Isn't it? Please say something. The IQ depends upon economic condition. That is the decision. I have said that we cannot say that. We cannot say that the IQ is independent of economic condition. Or some way we can say that the other way around it is the IQ level of IQ depends upon the economic condition. So that completes today's class. Thank you. Discussing chi-square distribution, and in previous days class we have discussed chi-square as goodness of fit and chi-square as degree of association. We also have chi-square as the test for population variance, but that part does not come very much, so I'll not discuss too many things. I have sent you the notes on that. Here in this case chi-square will be defined as uh, n minus 1 s square by sigma square, where chi-square when a test statistic chi-square will be defined as. So in this case what will be testing, that null hypothesis is sigma equals to sigma 0, alternate hypothesis is sigma not equals to sigma 0. If that is the case, then the corresponding uh, test is a test for population variance with a particular value sigma 0, and in that case that particular distribution follows a chi-square distribution, where chi-square is defined as I have defined. So n minus 1 s square, where s square is the sample variance by sigma 0 square. Actually, instead of sigma we will be putting the value of sigma as sigma 0 what there, and this chi-square follows n minus 1 degrees of freedom. This is n minus 1 degrees of freedom. Chi-square always has a degrees of freedom. So if n is the sample size, small s is the sample variance, then we are testing this for the null hypothesis that population variance is sigma equals to sigma 0. So then we will be using the chi-square distribution, and the chi-square statistics test statistic will be chi-square, and that will be calculated as n minus 1 into a square by sigma 0 square. And mind that if it's a chi-square not equals to 0, not equals to the alternate hypothesis, for alternate hypothesis it will be a two-tailed test. This will be two-tailed test. So this side it will be alpha by 2, and this side it will be alpha by 2, but here these two values will be different because there is no symmetric. Chi-square is not symmetric distribution. So here this if so if alpha is, say if alpha is equals to 0.05, তখন এই পয়েন্টটা হবে, this will be chi-square point 975, তাই তো? না ঠিক ভুল করলাম না, 0.05 বাদ দিলে কত হয়? 975 ভুল করলাম। So 0.05 কে দু ভাগে ভাগ করলে it will be, this side will be this area will be 0.025, 0.025, this area will be 0.025, and this area will also be 025 তাহলে from the table you have to find out, say if n is say 30 or 35, if n is 35, then if you check the table that I have provided, তাহলে দুটো ভ্যালু তোমাদেরকে চেক করতে হবে কাই স্কোয়ারের টেবিলে থেকে, then n minus 1 will be 34, so two values you have to check, এবং এরিয়াটা will be one sided, the area will be 0.975 and the other one will be এই সাইডে হবে 0.975, এই সাইডে হবে 0.025, so two values have to be checked or two values have, এখানে কিন্তু সিমেট্রিসিটি প্রপার্টিটা স্যাটিসফাই করবে না, জেনারেলি এই পার্টটা আসে না, সো আই এম নট ডিসকাসিং মাচ দিস পার্ট, বাট দ্য আদার টু পার্টস আর ভেরি ভেরি ফ্রিকুয়েন্টলি, that is chi square has goodness of fit and chi square has as degree of association, and similar kind of problems I have already discussed yesterday and I have already given in the group, so try those problems, calculation পার্টটা কিন্তু যথেষ্টই সোজা আছে, so please try them, ঠিক আছে। এখানে কিন্তু পরীক্ষায় যদি কোশ্চেন আছে, the data will be provided, mind that you will not get the table, the data corresponding data will be provided, so only thing you have to keep it in mind that this chi square is not symmetric, and in this case it will be n minus 1 degrees of freedom, and if it's a, if not, alternate hypothesis is not equals to sigma, not equals to sigma 0, it will be two-tailed test. If it's a, if it's sigma greater than sigma 0, it will be right tail test, and if it is sigma less than sigma 0, it will be left tail test, so accordingly you have to find the value, and but for the other two experiments, for not, this is parametric test, mind that this is parametric test, and we have already discussed the non-parametric test corresponding to the chi-square distribution. So for the non-parametric test, that is chi-square has goodness of fit and chi-square has degree of association, that is all, that both of them are always a right tail test, so the critical region will be always on the right, so critical region will be always on the right, so that completes our discussion on the chi-square distribution.